Greetings and welcome, friends. Mr. Waddy here. We are continuing our look at exponential functions. Exponential functions, that's right. And we're just having a good time here today. We're looking at example 4. We technically did some of these already the other day, but we're going to finish up this example and then talk about some different types of transformations, specifically translations of some of these functions. So here we go. Let's see. Let me see if I can. I'm going to open up this graph. So it says graph the function negative 1/2 to the x. Compare the graph with the graph of the parent function. Describe the domain and range. I don't think we got to that the other day. So we'll describe the domain and range. Let's see. I'm just going to invert colors for a minute. I know it's crazy. What's Mr. Waddy doing? Why did he invert my colors? No. All right, don't you worry, it's going to be fine. It's going to be fine. Let's see, where is my... All right, uninvert, bam. All right, whew, that was scary. I had to travel to, like, the netherworld for a moment. All right, so here is the graph of the parent function. And what I'm calling the parent function in this case is just y equals 1/2 to the x. Notice that the value of b, the base of this exponent, was between 0 and 1. So this is the classic situation where it's going downhill, where each one is being multiplied by 1/2 the height, then 1/2 the height, then 1/2 the height, then 1/2 the height of the previous y coordinate over intervals of 1. But now the question is, what would multiplying by this negative do? So this is like the a value is -1 for the a value. So it's not stretching it in any way, but what does the negative do to this graph? What do you think? Anybody? Well, we could pick a point and consider what happens. So here, y was equal to negative or positive 1, and multiplying 1 by a -1 would bring it down here, the -1. All right. Here, y was equal to 1/2, and multiplying 1/2 by a negative is -1/2, like so. Here it was a quarter, and multiplying a quarter by negative is going to bring it down to a quarter. Any theories as to what multiplying by a negative is going to do to our graph yet? Yeah, it's going to flip it over the x-axis here. Here, it had a y value of 2. Multiplying 2 by -1 would bring us to -2. And here it had a y value of 4. Multiplying that by -1 would bring me down to -4. So my graph, let's see, can I hit the points? Oh, so sloppy, gross. There we go, almost. Would look something like that. All right, something like that. So that's the graph of y equals negative of 1/2 to the x. So this was, in terms of transformations, this was a reflection over the x-axis. This was the x-axis here, is what happened. And then they asked us a question about domain and range. Now, domain, remember, are the possible x values. So are there any limitations on the x values that I could have plugged in this green function? Now, even though this is going super steep, I could theoretically plug in -10, right? I could raise 1/2 to the -10 and then multiply by -1. I could plug in -1,000,000. I could plug in -2 billion, all right? There's no restriction on the input for these graphs. So it's the set of all x such that x. It's just anything. It's an element of the real numbers. Right, it goes from -infinity to positive infinity. But the range, however, is interesting. Does the green graph ever equal 0? Does it ever hit 0 for a y value? Does it ever go above this? No. And it never even touches the x-axis. It just gets closer and closer forever, but never reaches it. And it does go down to -infinity. So the range is the set of all y such that y is less than 0, right? Y is less than 0. Everything up to 0, but not including it. Very good, very good. Let's see. Where am I here? Oh dear, where did I go? Let's talk about slightly. All right, we'll do these real quick, just because these transformations are a big deal, and I want you guys to know about them. All right, let's do. These are the monitoring progress questions 5 and 6, and let me actually just recolor is not going to do exactly what I want. That's fine. I'll just take them in their white on black. That's fine. I like to invert usually, but so here are the graphs of the parent function. So here's y equals 4 to the x right here. Notice the scale is super shifted, okay? And if I want to figure out what happens when I multiply this by -2, well, multiplying by the -2, here's the point 1, multiplying by -2, 1 times -2 is -2. It'd bring me like down here, I think. All right, at 1, this would have been at 4 high. What's 4 times -2? -8, so that would have brought me down to here, okay? Over here, when I plug in 2, 4 squared was 16, all right? And what's 16 times -2? 16 times the -2. -32 right there. And so the graph for this is both reflected over the x, reflect over x-axis, and what did the 2 part do to it? It was a vertical stretch by a factor of 2. All right, so it's twice as far from the 0 as it used to be. Okay, over here, the parent function is y equals 1/4 to the x. So that's this parent function right here, y equals 1/4 all to the x, okay? And since this, the base, the b value of 1/4 was between 0 and 1, that's why this was a downhill graph, right? Downhill. And we're multiplying it by 2. So what is that multiplying by 2 going to do? So right here, it's y-intercept was 1. Multiplying by 2 will make it 2. Okay? Let's see. So this was 1/4 to the x. So let's see. When I plug in, let's see. It's tough to see. This is -5. So here's -4, -3, -2, -1. So at -1, it actually would have been 4 high. And multiplying by 2 would have brought it up to 8. I'm just doubling its height. At -2, it actually would have been 16 high. And what is 16 times 2? 16 times the 2. Just going to double its height. Bring us to 32. And then the same thing here, whatever this height was, I would double it and etc. And so if I, oh, I'm not going to draw this well at all. Terrible. Technically, this green curve is always going to be twice as high as the purple curve. It would look like this. So that multiplying by 2 is a vertical stretch by 2. Is what that multiplying by 2 does. Question, comment? Yes, yes. All right, so let's take a look at different types of transformations here. And it says, what if I want to do horizontal or vertical shifts? Horizontal or vertical shifts. So this is what it says. To graph a function of the form y equals a times b to the x minus h. So I want to point out that the x minus h is all in the exponent. And then plus k is back at the level of everybody else. Okay? Begin by graphing the parent function, and then translate the graph horizontally h units. So horizontal by h and vertical by k. And notice that it does the weird opposite of h thing. Opposite of h is what I end up getting. And so this is going to be a little bit interesting. It's going to be a little bit interesting, but it is actually something we've done before. If you recall, actually, let me switch this to projector mode. Shows up a little bit more solid. So back when we were doing absolute value graphs, remember that when I changed the k value, the number that was on the outside of the parentheses, it was a vertical shift by that number. So when k is 5, notice, it's up at 5, right? And h, when h was positive, now notice that this I've already got in the minus h form. It shifts it horizontally speaking, but according to the function, it actually would have been a -1. Or sorry, there's the one that I'm talking about. -1. So the h, when I'm changing the x, when I'm adding or subtracting something to the x, it's horizontal. And when I'm adding or subtracting something after everything else has happened, it's a vertical transformation. So that's what we've seen before. And notice that is exactly what we're looking at with exponential functions. When I shift by k, notice it's actually shifting up and down. And notice what's interesting about that is that actually changes where my asymptote is, where it was, right? It used to get closer and closer to 0 and never get there. But now with a +3 on the outside, notice it's actually getting closer and closer to 3, but is never going to reach 3. Okay, or if I had it down at like -1, now it's getting closer and closer to -1, but is never going to get there. And a horizontal shift is going to be, there we go, the h value, and it shifts it left and right. That's a little bit weirder and harder to see, but that is what's happening. And the way I think about horizontal shifts is with respect to their original y-intercept. The y-intercept is going to be whatever a was. Okay, so if a was 5, all right, there's the point 0, 5. And now if I move by h, change h to 1, now instead of 0, 5, notice I have the point 1, 5. All right, so that's kind of the quickest way to recognize where your horizontal transformation ends up being. So let's do an example of this together and see how this goes, figuring out these transformations. All right. So graphing y equals a times b to the x minus h plus k. All right. It says graph the following and describe the domain and the range. Okay. So what I've actually got for us here is a parent function that's already done the stretches and everything else. It's all stretched and ready to run. Okay. Actually, maybe that's what we should first do. Let's label A, B, H, and K. Let's do that. What is A in this graph? In this equation? Comparing to these values up here. What is the A? What is a equal to, comparing this to the general form of it? The a must have been the 4. All right. What was the base of the exponent? The 2. What is h equal to? Now this is the tricky part. -3. This is always of the form minus h. So that means h must have been +3. Okay, that's kind of weird. And the +2 would have been the k. All right, that's what I get. Now the original graph, let me label these, and you guys can as well if you want. The original graph, this was y equals 2 to the x. Plain old y equals 2 to the x. Notice, yeah, so it had a y-intercept at 1. And then at 1, 2 right there, and then 2 squared was 4, and 3 squared was, no, sorry, I just said 3 squared. 2 to the 3rd, different than 3 squared. 2 to the 3rd is 8, right? And 2 to the 4th is 16, so you can see that. Now multiplying by the 4 resulted in a vertical stretch. So this graph is y equals 4 times 2 to the x. All right, so we know how to do that. But now I've got to figure out, what do these translations do to us? What will these translations do to us? Okay. And since h was 3, okay, this is going to be a horizontal shift. All right. Now h was the opposite of this number. Okay, so this is going to shift this graph. Actually, let me pick some of those points first. So here's the point, right, 0, 4. Let's see, 2 times 4 was 8 high, so that was 1, 8. Let's see, 4 times 4 is 16, right? So there's some points for me to reference. I also had right here, looks like -1, 2, what I've got. Okay, so with those points, now I've got to think about these in terms of shifting them. All right, so I'm going to shift to the right 3 units. So this is now going 3 to the right. That's 1, because notice there's a 1. All right, 2, there's 2. And 3 would have landed right there. So 3 to the right, and it's going up 2. So right 3, up 2. And so to go up 2 from 4 brings me right here, where I land. Let's see if I can fit the other one. I think I can fit this one more point. So moving this point 3 to the right lands me all the way over here at 4. And I'm going to move up 2 units. All right, so up 2 units, 8 plus 2 is 10. Let's do this one as well, and this will be the last one we do. So this one now gets shifted 3 to the right, so there's 1, 2, 3, and 2 plus 2 is 4. Actually, that's weird that that point happens to land on the purple graph. But there we go. And I guess we could hit one more. We'll hit one more. So this was at 1 unit high, so -2, 1. I'll shift that 3 to the right. So that lands at 1, and then up 2. 1 plus 2 is 3. Now the new y-intercept, that's actually going to be tricky. I think would have been this number here. Let's see, this was a half. Yeah, it's going to cross at a half, I believe. No, a half, sorry. 1/2 plus 2. So it's going to be at 2.5. There we go. Now, the new asymptote, all right, it used to approach 0. It's now going to get infinitely close to 2 and never reach it. So there we go. So my graph, ooh, can I do it? I'm going to try to hit them all. Nope, nope, nope. Is something like that. Whew. That was pretty ugly. But that's the idea of this graph. It was, in terms of transformations, this was a vertical stretch by 4, vert stretch by 4, and then it was shifted right 3 and up 2. And so the way you would do this is using the parent functions, and I'm going to, as best as I can, just kind of equip you with those, and then you're going to just do the shift piece of it, is what you end up doing. So let's look at one more of these. That might be as far as we get today. We'll do just question 7 from the monitoring progress. And did I end up giving you guys those graphs, or were they not ready yet? Well, here's the graph. Let's see, did I end up having that ready for you? 6, I think I did. wonderful, wonderful. Okay, so let's label A, B, H, and K. So A, B, H, and K. What was the A equal to here for this equation? That would have been the -2. The base was what? The 3. H is going to be the opposite of this number, so H is -2, exactly. And K was -1. So I'm expecting this -2 was a reflect over the x-axis is what happened. Right, that's what the negative did. The 2 was a vertical stretch by 2. And the H will result in a horizontal shift left 2 units. And the -1, what does that -1 do for the K? A vertical shift. Which way is that going to move it? What's this -1 do to my graph? Well, it's being subtracted from it. All of these values are being subtracted by 1. So it's a vertical shift down 1. Okay, so now the question is, which one was my original graph? It turns out this orange graph this time was y equals 3 to the x. The purple graph was y equals -2 times 3 to the x. That didn't land in there. Y equals -2 times 3 to the x, right? Because you could see this point was flipped upside down and doubled. And yeah, I didn't even have those show up, but that's okay. This is the point. So this is 0, 2. This is 2, -18. What would 1 have been? 3 times -2, -6. Okay, so we'll use those as some of our reference points for our shifting. And so now for our shifting, let's take this point. I'm shifting left 2 units. So notice my scale, first of all. So here's -1. There's -2. So I'm going to go left 2 and down 1. And 1, in this case, I believe is a half of a grid. All right, because this went from 0 to -10, and I had 5 spaces. So those were counting by 2s. And so I'm going to go down half of that spacing. All right, let's do this one. So this was at 1. I'm going to shift left 2, so that's going to bring me over to the -1, horizontally speaking, and then down half of my grid, right, which was the same as down 1 unit. Let's see, let's try this. So this is at 2 on the x, for its x coordinate. So shifting left 2 is actually going to bring us to 0. And then I'll move down half a unit, or half a grid, which is 1 full unit. So this is actually 0, -19 now. Now, where is my new asymptote? Because both of these graphs originally were approaching 0, but this -1 is going to result in my new, my new asymptote, where it's going to get closer and closer to -1, which is not on the grid, right? It's halfway between those. And mine didn't quite work out. But my graph looks something like this. The end there was a complete failure. But that's roughly what it would look like. And that's the sort of thing that I'm hoping for you to be able to do on the homework, as well as the test. All right, thanks for watching, Internet friends. Have a great day.